In this video, I'm going to talk about the Fischer-Indole synthesis mechanism. Now, this mechanism, in this mechanism, there are two things I want you to understand. You need to understand that this mechanism always require you to have two things. Or whenever they ask you to write the mechanism, this mechanism, you, you need to have two things in place. So this mechanism always involves a compound having two nitrogen. In this case, you have this compound right here. It's not going to have a benzene ring always, but one of the reactant must have these two nitrogen present. So this is called the phenylhydrazine. So in this case, we are given a phenyl. This is a phenylhydrazine. And also, you must have a compound having this group. Only then this reaction will proceed. Now, this can be a ketone, like in this case we have a ketone compound. And if it's not a ketone, you can have an aldehyde where this group is replaced by a hydrogen. So you are going to have that whenever they ask you to write this mechanism. So keep that in mind. Now in this, for this one, we are given an acid, which means this is the acid catalyzed reaction. So every acid catalyzed reaction is going to proceed by activating this group. So this is where the oxygen of the carbon is going to be activated. So let's go over the push arrow mechanism and see how this reaction proceeds. So the first step is the activation of the carbon. So this is where the first step is the activation of the carbon. So the activation of a carbon group. So in this reaction, I'm going to use the hydronium as an acid, since they just say trace acid. You can use any acid, but in this case, I'll proceed with the hydronium. So this is what I'm going to use. I'm going to use this acid. So this is called hydronium. So I'm going to use that for the activation of a carbon. So now I'm going to use the acid. So this has a formal charge of +1. So what will happen is that this, a lone pair of this oxygen is going to abstract this hydrogen right there. So there's going to be a proton abstraction from the acid. So this oxygen is going to abstract that proton, returning these electrons back to the oxygen. So this is going to give us this compound. this is going to give us this activated compound right here. And this oxygen will have, whenever oxygen is connected to 3 bonds, it possesses a formal charge of +1. So this is the activated compound that we have after being activated. So this is the activated ketone compound that we have. So we're also going to have water from this reaction. So from this reaction, we're also going to have water as one of the product. After this reaction, we abstract one hydrogen, and then we're going to remain with water in this case. So now, what will happen next is that we are going to use the phenylhydrazine, and this compound is going to react with this activated ketone. So let's see what happens next. So when you get a hydrazine compound, okay, that's a benzene ring. In fact, let me write bonds in a different color so that you can easily follow through. So I want you to follow through of every step and see what is happening. So you have to understand that these nitrogens here have got a lone pair. So the maximum bonds which are, or electrons, the nitrogen, the outermost shell, the outer valence the nitrogen can carry, it's 5. So having 5, only 3 bonds are connected. So when you look at the electrons which are direct attached to this nitrogen, it's about 3. We have 3 bonds connected to it, and this gives it, when nitrogen is connected to 3 bonds, it possesses a formal charge of -1. So this -1, okay, so this nitrogen is going to use its lone pair and attack the most positive carbon of the carbon. So this is going to use its lone pair and attack that there. So this will force this pi bond to break towards the oxygen atom. And so what we are going to have is the combined product of a phenylhydrazine as well as a ketone product. Okay, so this is what we are going to have. As you can see, the two nitrogens are there, and then we just use the lone pair of this nitrogen to create this bond right there. So this is what we have after this reaction with the activated carbonyl compound. So now, since we have this, remember that this methyl here has got 3 hydrogens connected to it. And so this lone pair of the oxygen is going to reach out for that. Let me use a different color so that you can easily follow through. So the lone pair of oxygen is going to reach out for that hydrogen. And so this proton will collapse towards this bond. Okay, let me say this will collapse towards this, creating a double bond. Once that bond is formed, this bond connecting oxygen and the carbon, or the carbonyl carbon, the carbonyl, the oxygen carbon bond would disconnect. So this would disconnect this bond towards oxygen. So this water will leave. So we have H2O minus from this. And so from this step, we are going to have a product without water molecule. So from this step, we are going to have this product. Remember, we have created a double bond there. That's 2 nitrogen atoms. So this is what we have now. So the double bond are still the same in this case. They are not affected. Now, I want you to look at the nitrogen and see what is happening. So this nitrogen has got 2 hydrogens attached to it. This one has got 1 hydrogen. Now, remember I said that when a nitrogen, they are supposed to have 5 electrons. But when 4 bonds are connected to it, it will have a plus charge of +1, a formal charge of +1. So now this one is connected to 3 bonds, so it will still maintain the electron there. So now this is very unstable for nitrogen, and it's likely to disconnect. And so what will happen from this step is that this lone pair right here is going to reach out for that double bond. And so what will happen is that this lone pair here will attack this bond right there, breaking this pi bond, collapsing towards this nitrogen. The pi bond between 4 and 5 is going to break and attack this double bond there. And so this double bond will break, will collapse towards nitrogen. And then this bond, okay, so this will create a double bond here. So at this step, I want you to notice something. Every carbon which I've numbered here, I want to see how they are going to connect. So from this step, this pi bond from the benzene ring, this one here, right here, is going to use one of its pi bond, is going to disconnect and attack this double bond right there, carbon number 3. And this carbon 2,3 will break one of its bond, collapsing it towards a nitrogen. Once that happens, to create a double bond between 2 and nitrogen, and then this would disconnect this bond towards the other nitrogen. And so the product that we are going to form is this. So this is going to create this. So we have a bond there between 1 and 2 bond, which is 1 and 2. And then we are going to draw a 2 and 3 bond where the pi bond has just broken. We no longer have a double bond between 2 and 3. And then we are going to create the new bond which we just formed between 3 and 4. So we have a 3 and 4 bond right there. And then we draw a 4 and 5 bond right there. And then we are going to draw the 5 to nitrogen bond, which is right there. So we put a nitrogen right there with its hydrogen. And also, the bond between nitrogen and nitrogen has just disconnected. So we have a 2 to nitrogen bond, which is right there. And we created a double bond there. So we have a nitrogen connected to it with the other 2 nitrogens right there. So this is what you're going to have. And also the 4,5 bond is connected to the benzene ring, which I've just drawn there. So this is what we are going to have from this step. So we just remove the bond there. So what we actually have is this and that. So we have lost a bond there. So this is what we are going to have. Now, from this step, I want you to note something. So this nitrogen is still connected to 4 different bonds. And so what does that mean? This nitrogen still have a formal charge of +1. So it has a formal charge of +1 there. That means it is very unstable and is likely to disconnect. So it has a formal charge of +1. And this one is connected to 2 bonds plus 1 hydrogen. So this gives it a lone pair. When it's connected to 3 different bonds, it still possesses that lone pair. So what will happen is that this nitrogen with a lone pair is going to attack an imine. So what we have just created here is an imine. So if you want to understand what an imine is, please watch my other video about alders and ketones. Watch my other video about the amines that I've created if you want to understand what an amine is. So this will break this bond towards the nitrogen. And so the product formed is going to create a ring. And see what product is going to be formed from this step. So after that reaction, we are going to have this product. So I'm going to number this as well so that you can easily follow through. So I'm going to number this carbon number 1, carbon number 2, number 3 there, 4, 5, and also the 2 nitrogen. So what is going to form here is this. So we have just created a new bond. So let me redraw that. Carbon 2, 3, this one. And then we have that plus this nitrogen, which just attacked pi bond. So we have this with a new bond, which we just created there. This is very easy to follow if you know what is happening here. So this is attached to the benzene ring. So this is attached to the benzene ring. We still have these bonds here. And we still have these bonds too. So now, what has changed is this bond that we have just created here. So this still have a nitrogen. And also I want you to notice that we just disconnected this bond here. After creating this bond, so after creating this bond between this nitrogen, the lone pair, and to carbon number 2, we broke this pi bond here towards nitrogen. So which means that this carbon still have a nitrogen connected to it. So this is what we have. So this lone pair of this nitrogen will reach out for that hydrogen. Or if it's not this hydrogen, it can also get a hydrogen from water in solution. Okay? It can get hydrogen from water. So this lone pair will still get a hydrogen from water. So this will give it a positive charge. And so the lone pair of this nitrogen is going to create a double bond. Is going to create a double bond there, and this would disconnect this group towards oxygen. So that means we're going to have an amine in solution. So the next product formed is going to be this benzene ring here, which we have just maintained, connected to this compound right here. Like that. And this is also okay. We're still having double bond, and here double bond. This is a double bond, and this still have a double bond like that. So what we have just created from this lone pair delocalization, we're going to have a double bond. We have put a double bond there, and this amine has just disconnected as amine in solution. So this is what we have created so far. Now we're still missing a bond here. So how do we put this bond back in solution? So remember that we have an amine solution. So this amine, after disconnected, we have an amine in solution. So this amine still have a lone pair. So this can still abstract that hydrogen. Sorry about that. We have an amine solution. So what I meant to say is that this benzene ring has a hydrogen right there, solution. So this amine will easily reach that hydrogen and abstract it. So this proton will be abstracted, and this bond will collapse towards the benzene ring. And so the final product that we are going to form in solution is an indole. So the final product formed is an indole, which we are looking for, which is the product that we are looking for in this reaction. So we are going to have an indole product right there. So this is going to put a double bond inside, like I said earlier. So this will put a double bond there and there, like that. So you can clearly see that the product we have created here is similar to what we have there. So this is the same product as this one. So this is how you go about running this mechanism. It is exactly by following these steps. So this is an indole product. This is an indole product. And so the other product that we also have the water. We have reformed the acid in solution. So we have H3O in solution. So that's all for this video. And I hope this has helped you exactly on how to run this mechanism. The only critical points that you need to understand is the 3 to 3 rearrangement that is happening at this step, where this nitrogen here have to attack this imine, and so this disconnect the double bond so that we can get rid of one amine which will leave into the solution. And also the other critical point that I would want you to understand is the creation of this alkene at this product here. So you really have to understand how to create this double bond, because this pi bond from the benzene ring, once it delocalizes, it is going to attack this alkene here, breaking a bond towards nitrogen. So this puts up a pi bond or a double bond between 2 and the nitrogen. And so once that happens, you have this product here where the 2 nitrogen disconnect to each other. So one nitrogen carrying a pair of electrons will attack the positive carbon connected to a nitrogen, and this will break it. And once it breaks, it's going to create the Indole product. So once you know how to run these 2 steps, this one, if you can achieve this product here, and also these are the 2 important points that you have to understand how the reaction is happening. So the rest are very much simple and easy to follow. So thank you very much for following through. If you have a question concerning this, please send me a text on WhatsApp, and I would also want to notify you that I do conduct a one-to-one tutoring online lessons. So you might have a tutorial sheet, questions from tutorial sheet, especially for those students from Unza, CBU, Mulungushi, and any other part of Africa. So if you are interested, you can text me on this number on WhatsApp. We make arrangements. So my number is 0962 334973. Send me a message on this number here. +26 0962 334973. So send me a text. So this should be for the online lessons request. So send me a text on this. So the other courses that I would take you through is the chemistry analytical. That's analytical chemistry. So the course code is should be 2219, and the chemistry, arene chemistry. The course code for this one is 2522, and also stereochemistry. The course code is 2511, and many other foundation chemistry courses under natural sciences at Unza. So if you are struggling with any of these courses, please send me a text on this number and then I'll respond to it. Thank you very much for watching this video. I want you to notice that so this benzene ring right here is going to use this pi bond. From the numbering, I'm sure you can see the position of the carbons. So this pi bond is going to break the